We are starting a series of videos that will cover Unit 3 in our pre-calculus open courseware. Unit 3 is an introduction to trigonometry. And in this video, we will talk about angles. Again, in the pre-calculus textbook, this would be Chapter 5, Trigonometric Functions. And specifically, we will be in Section 5.1 discussing angles. So first, we need to know some terminology. What is a ray? A ray is a part of a line that has only one endpoint and extends forever in the opposite direction. What is an angle? An angle is formed by two rays that have a common endpoint called the vertex. One ray is called the initial side, and the other ray is the one that rotates, and it's called the terminal side of the angle. A rotating ray is similar to the hand of a clock. We draw an arrow by the vertex, starting at the initial side and ending at the terminal side. We use Greek letters to name angles. Most common are alpha, beta, theta, and phi. An angle in standard position is an angle that has its vertex at the origin of a rectangular coordinate system and its initial side lying along the positive axis. Positive angles are generated by rotating the terminal side in a counterclockwise direction. Negative angles are generated by rotating the terminal side in a clockwise direction. An angle lies in a quadrant that its terminal side lies. And for example, the angle that is shown on the figure on the right has its terminal side, which is this one, in quadrant 2. Therefore, so this is quadrant 2. Therefore, this angle is an angle that lies in the second quadrant. If the terminal side is on the x-axis or the y-axis, the angle is called a quadrantal angle. Complementary angles add to 90 degrees, and supplementary angles add to 180 degrees. The main drawing, the main sketch of complementary angles will be a right angle, and then two angles will fit that are complementary will fit within that 90-degree angle. Supplementary angles, the main drawings, the main sketch would be a straight line and then two angles that can fit on that straight line. So this will add to 180 degrees. A full circle is 360 degrees. A right angle is 90 degrees. A straight angle is 180 degrees. An acute angle is less than 90 degrees and it's positive. An obtuse angle is greater than 90 degrees. So let's call it theta, will be greater than 90 degrees, but it will be less than 180 degrees. And a convex angle will be greater than 180 degrees. An angle that is complementary to 30 is 60 degrees because 30 plus 60 will be 90 degrees. An angle that is supplementary to 30 will be 150 degrees because 150 plus 30 will give me 180 degrees. An angle that is complementary to 23 will be 67 degrees, and I will find 67 if I do in my calculator 90 minus 23. An angle supplementary to 123 degrees will be 57 degrees. I will find 57 if I do in my calculator 180 minus 123. Two angles are complementary One measures 5x degrees and the other 4x degrees. Find the degree measure of each angle. So we have angles alpha and beta. They are complementary, so they add to 90. Alpha is 5x degrees and beta is 4x degrees. So I need to find x and then find how much is 5x and how much is 4x. So if I substitute 5x and 4x in the equation at the top, I will get 5x plus 4x equals 90, which makes 9x equal to 90, which makes x equal to 10 degrees. And therefore alpha will be 5 times 10 degrees, that's 50 degrees, and beta will be 4 times 10 degrees, which is 40 degrees. Two angles are supplementary, so alpha plus beta is 180 degrees. One measures 7x degrees, that will be alpha, and beta measures 5x plus 36 degrees. Find the degree measure of each. Therefore, I will do the same thing. I will substitute in the top equation 7x plus 5x plus 36. I'm supposed to substitute in parentheses and then distribute, but because this is just alpha plus beta, so they are just multiplied by 1, I am skipping that step. Equals 180 degrees. That will be 12x plus 36 equals 180 degrees. I will subtract 36. 12x is equal to 144 degrees, and therefore x is equal to 12 degrees. So alpha will be 7 times 12 degrees, and that is 84 degrees. And beta is 5x plus 36, and x is 12 degrees. And that will equal to 96 degrees. And it is true that 96 plus 84 will give me 180 degrees. Now, degrees are nice because they mean something to us. We are used to them. But in algebra, we use real numbers instead of degrees. And for this reason, we need to introduce the radian measure. An angle that has a vertex at the center of a circle is called a central angle. 1 radian is the measure of a central angle that intercepts an arc of length equal to the radius of the circle. So if the radius of the circle is r, we want the arc intercepted by that central angle to also equal to the r, have a length of r, and that will be 1 radian measure. So the radian measure of any central angle is equal to s divided by r, which is the length of the arc intercepted by that angle divided by the radius of the circle. Now, this is in your packet, and it is actually here, solved for s. So the length of a circular arc, s, will equal to r times theta if theta is measured in radians. Now, in radians, a full circle will be 2 pi r, which is the circumference of a circle divided by r, so it will be 2 pi. Therefore, 2 pi will be 360 degrees, and half a circle will be half of 2 pi, so it will be pi. Pi radians is the same with 180 degrees. So we have some formulas that we will be using in a minute. In our formula packet at the bottom of our second page that says that if you want to convert from radian to degrees, or if you want to convert from degrees to radians, you will use a ratio that is pi radians equals to 180 degrees. One thing I want to draw your attention to is that radian measure has no units. And the reason it has no units is because the length of the arc and the length of the radius are measured in the same units. So when you have S divided by R and you have meters in the top and meters in the bottom, these will go away, will cancel. If you have inches and inches, they will cancel. If you have centimeters and centimeters, they will cancel. Millimeters and millimeters, they will cancel. So radians actually are just plain numbers, real numbers. They don't have units. We put a placeholder, we write rad for radians so that we know that we are talking about radians, but that radian unit is actually not a unit, it's just a placeholder. So from degrees to radians, we multiply by pi radians over 180 degrees, and from radians to degrees, we multiply by 180 divided by pi. Now, you are welcome to use these conversion ratios to do the conversion between degrees and radians back and forth. And the videos in the Ohm course do indeed use the formulas, but I am trying to not use formulas if I can and not use my calculator because it is faster for me and most of the times it is easier to do the calculations mentally. So the way that I do it is that actually I have memorized that 180 degrees is pi, and obviously 360 will be 2 pi. Also, I have worked with the trigonometric circle a lot, which is part of our packet over here. And this trigonometric circle shows me that 0 and 360 degrees is 0 and 2 pi, and 180 degrees is pi. So I have used the trigonometric circle enough to remember that pi will be at 180 degrees, and that's the one thing that I definitely want to remember. And 0 and 2 pi will be at 360 and at 0. So 90 degrees will be half of 180, and therefore it will be half of pi, pi divided by 2. 45 is a quarter of 180 because it's half of 90. So half of pi halves will be pi quarters, or 4 45s will give me 180. 60 degrees is 1/3 of 180 degrees, so pi divided by 3. 30 degrees is 1/6 of 180 degrees, so pi divided by 6. And again, I can confirm that because in my formula packet, the 30 degrees, the 45 degrees, and the 60 degrees, and the 90 degrees are stated as fractions of pi, pi being 180 degrees. So the angles that are shown in my trigonometric circle, and they will be the most popular ones that I will be using in my class, in my algebra classes, are some familiar fractions of 180 degrees, and I remember that. So backwards, and again, if I don't want to use my calculator too much, 2 pi will be 2 times 180, so 360 degrees. Pi tenths will be 1/10 of 180 degrees, so 18 degrees. Negative pi 12ths will be 1/12 of 180 degrees. So for that, I will use a calculator. I will say how much is 180 divided by 12. In my calculator, the answer is 15 degrees. Don't forget that this is a negative angle, so negative 15 degrees. 180 divided by 3, 60 degrees. This is negative, so negative 60 degrees. Negative 5 pi thirds. So this is a very common situation where we'll be working with. And again, I'm trying to use mental math, which is faster than using the calculator, but I can always use the calculator if I want. So what I do here to do the math is actually I focus on the fraction of pi. Pi over 3 is the 60 degrees. So I have negative 5 times 60 degrees, and that will be negative 300 degrees. Now, for 1, I cannot do that math. A radian is an irrational number. Pi, as you know, which corresponds to 180 degrees, is an irrational number. So 1 looks like it's an easy number, but rotationally, as an angle, it is actually an irrational number. So the only thing we can do is we can find an estimation. So let's use our calculator. Oops. Let's use our calculator for that and the formula. So according to the formula in our packet, if I have a radian and I want to convert to degrees, I have to multiply by 180 and divide by pi. So if I do that, 1 times 180 and divide by pi, the answer will be approximately 57.3 degrees. So when you are drawing a radian, you want it to be approximately 57.3 degrees, which is very close to 60, but not exactly, maybe a little less. So the radian will be starting from 0 degrees and going to 57 degrees, which would be somewhere there. That will be 1 radian. So approximately 57.3 degrees. Now, again, we want to familiarize ourselves with finding slices of pi indicated by the denominator. So pi quarters, remember pi is from 0 to 180. Positive angles go in the order of the quadrants from 1 to 2 to 3 to 4. So pi quarters will be a quarter of that. Here, that will be theta. That's pi over 4. And where would be 9 pi quarters? So 9 pi quarters means that I'm looking for quarter slices of pi, and 4 of them will get me to 180. So 1, 2, 3, and 4 will get me to 180. 5, 6, 7, and 8 will get me back to 0 if I keep going. And then 9 pi quarters. So I'm treating this as 9 times pi quarters. So 9 45-degree angles will actually also land me in the same spot. So 9 pi quarters will be exactly where pi quarters was, only I would have done an additional rotation on the circle. Negative 3 pi quarters, I have to go in the negative direction, and I need to do quarters of pi. And again, remember, pi will get me to 180, but from the negative direction. So 1, 2, 3, that's where negative 3 pi quarters will be. And I'm moving from 0 to the negative towards the negative direction. If I want to do 5 pi quarters, which is now positive, I'm going to again move in quarters. So 1, 2, 3, 4 to get to pi, and 5 to get me also at the same spot. So negative 3 pi quarters and pi quarters is the same location on the circle. Now, negative 11 pi fifths, I actually do not need to know how much is pi fifths. I just need to know that I need 5 of those to get to 180. And first I'm going to start in the negative direction, and I'm going to do 1, 2, 3, 4, 5. And now here I will be at negative 5 pi fifths. Negative 5 pi fifths will be negative 5. Then I need 5 more, 6, 7, 8, 9, 10, and now I will be here, negative 10 pi fifths, which is the same with negative 2 pi. And I need 1 more to do the 11 pi fifths. So here is negative 11 pi over 5. To do the positive 19 pi fifths, I'm going to go in this direction, and I'm going to be doing 1, 2, 3, 4, 5 to make a circle. So that will be positive 5 pi fifths. Then I will do another 5, so 10 to get me here. Then I'm going to do another 5, 15 to get me here. And then I don't have 5 more to go to 20. I need 4 more to go to 19. So 16, 17, 18, and 19, that will still be the same location. So negative 11 pi fifths and 19 pi fifths again is the same location on the circle, starting at 0 in standard position. These angles are called coterminal angles. Coterminal angles are angles in standard position that have the same terminal side. So we saw pi quarters and 9 pi quarters being coterminal. We saw negative 3 pi quarters and 5 pi quarters being coterminal. And we saw negative 11 pi fifths and 19 pi fifths also being coterminal. Now, in terms of degrees, the angles 132 degrees and negative 588 degrees, are they coterminal? The problem with degrees is that the numbers are very complicated. So the way to find if angles are coterminal is to see if the difference of those angles or the sum of those angles, ideally the difference of the angles, if they are whole circles being 360 degrees. So the way we do that, we use our calculator here with degrees. Degrees are very difficult to work with, even though they are very easy to imagine, right? Because I know, for example, that 132 degrees is somewhere here. And the question is, where is negative 588? So the way to do that is to take negative 588, wherever it is, and just add 360. And I get negative 228. And I'm going to add another 360, which is another circle. And I will end up in 132. So actually, I know that negative 588 is also in the same location. So the answer is yes. So how did I find that? I took one angle theta. Let's say that this was the 132 degrees. And then I took theta plus 2 times, my K was 2 of 360 degrees, and negative 588 plus 360 gave me 132. So in degrees, theta plus K times 360 will land me in the same location. In radians, I will do K times 2 pi, and that will give me the coterminal angle. If I land in the same spot, then they will be coterminal, and that will be the equivalent, and that's how I will know. Now, when you are working with fractions of pi, you actually don't want to use pi. Pi is an irrational number. We want to just use the fraction part. So for example, if I were to use this property for these two angles, I would start with negative 11 fifths. I will imply that the pi is there. So negative 11 divided by pi by 5. These are pi slices. And then I will add 2. Instead of 2 pi, just add 2. And I get to negative 0.2. And I'm going to add 2 again. And I will get to positive 1.8. And let me see what's the fraction for that. Oh, it's 9 fifths. And then I'm going to add 2 more. and I will get to 3.8, and then let me check what the fraction is for that, 19/5. So I see that negative 11/5 of pi and 19/5 of pi are actually coterminal angles, and that is because I added 2 pi 3 times. Now, if I want to do theta minus 360 in terms of pi, of radians, that will be theta minus 2 pi. And in this case, that k is -1. So this is a very common exercise, so we need to know how to do this. I'm going to put some stars here for us so that we know that we need to know how to do that. We want to find a positive angle less than 360 that is coterminal. Let me fix that typo. With 1524. So what I'm going to do is I'm going to take my calculator and I'm going to do 1524 and I'm going to keep subtracting 360. Minus 360 minus 360. I'm still not within the circle, right? But within 0 and 360. Minus 360 again. Minus 360 again. And the answer is 84 degrees. So as soon as I hit an angle from 0 to 360, that was 84 degrees. It is coterminal with 1524 degrees. How did I find it? I subtracted 360 4 times, right? So 1524 degrees minus 4 times 360. That was 84 degrees, and that's how I find the coterminal angle. Find a positive angle less than 2 pi that is coterminal with negative 24 pi fifths. And again, I'm only going to take into consideration the rational part, which is the fraction of pi. And I'm going to now add 2 pi's, right? So I'm going to have negative 24 fifths. And I'm going to add 2. And I'm going to add another 2. I'm still negative. And I'm going to add another 2. And I'm positive now. And then I'm going to convert this into a fraction. And that will be 6/5 of pi. So negative 24/5 of pi. And I added, I want to say 3 times 2 pi. How do I know? 2 pi, if the denominator is 5, will be 10 pi. So to make negative 24 a positive quantity, I need to add 10 pi and 10 pi and 10 pi, 30 pi fifths to make it positive. It became negative 24 plus 30 fifths pi, which was 6/5 of pi. Now, do you remember how to find the location of this angle? I start here at 0 and I need 5 of them, 5 slices. The denominator tells me how many to get to pi. So I need 1, 2, 3, 4, 5, and I need to sketch 6 pi fifths. So I need 1 more fifth, 6 pi fifths, and here it is. And this is also the location of negative 24 pi fifths. Don't set them equal to each other. They are not equal to each other. They are coterminal, which means as you rotate around the circle, you come by the same spot multiple times. The usual picture that you will see on tests, on the final exam, graphing grids looks like that. The one that you have on the left is the one that you have in your formula packet. The angles are multiples of 30 and 45. The angles on this circle, and here it is for you to sketch. So if I want you to sketch an angle, let's say where is the angle 9 pi quarters that we had here. If I need you to sketch this 9 pi quarters, I'm going to give you something that doesn't have the lines so that you can put it in the correct place. And the 9 pi quarters would be here. Pi quarters is exactly halfway between 0 and 90 degrees. So 9 pi quarters will be over there, for example. This concludes the first part of our introduction to angles. And we will finish section 3.1 with a separate video where we will work with applications of angles and radian measure.